Hello students, how are you? So this is the last and fourth question from 2025 FRQ AP Physics. Let's see what's there in the question, and the question says that in scenario 1 the swimmer holds a block of mass m at rest in the tank of fresh water with density ρ1. So here's the densities ρ1 given to us. The block released from rest and accelerates upward with the initial acceleration of a1. All frictional forces are negligible. Okay. In scenario 2, the swimmer holds the same block at rest in the tank of salt water with density ρ2, where ρ2 is greater than ρ1. The swimmer again releases the block from rest and the block accelerates upwards with initial acceleration a2. All the frictional forces are negligible. So the question is now, question says that, and I indicate whether a1 is greater than, less than, or equal to a2 by writing one of the following. So first understand, suppose this is the ρ1 and this is ρ2 and ρ2 is greater. So here there is an object. So this object is going up with acceleration a1 and this is moving with a2. So in both of the cases, the downward force is mg. And there is a change in the buoyancy force in both of the cases. Why? Because buoyancy force is the weight of the water that has been displaced by this object. So what is that? That is rho gv, and rho is of water. So we can say that this is equals to rho1 gv, and here it is rho2 gv. So being gv and gv are same, so it solely depends upon the density of the water. So if the buoyancy force is more and mg is same, so obviously the acceleration will be more for the second case. So it says justify your answer in terms of all forces exert on the block in each scenario. Use qualitative reasoning. So we have done it. You have to write all those things. Consider the general case where the block of mass m and volume v is completely submerged in a fluid of density rho. Starting with the Newton's second law, derive an expression for the initial upward acceleration a of the block when the block is released from rest. Express your answer in terms of mv rho, physical constants and appropriate. Okay, so basically what you will do now, this is rho v g and this is mg, and there is an acceleration upwards. So f net, you can write like this, that f net is equal to rho gv minus mg, and this will be equal to ma. Ma will be equal to rho gv minus mg. So the acceleration will be rho gv by m minus g. So this is the numerical representation of acceleration that we required. Consider the general case where this is starting with the Newton's second law, drive an expression for initial upward acceleration a. Okay, that's it. Indicate whether the expression for the acceleration a you derived in part B is or is not consistent with the claim made in part A. So in A we have said that A2 is greater than A1 because density of second water, that is salt water, is more than the fresh water, that is rho1. So this also tells us the same, because this row, if this row will be more, the numerator will be more, and if this numerator will be more, then this whole term will be more. So if A2 will be more than A1 because the density is more than the density. So this is how you have to write. You have to write all these things in point-wise manner, because it's a theoretical paper. You have to write all the points to gain marks. So this is how you have to solve it. You can just look into it again. So I don't think that there is any issue now. So if you still have some doubt, you can definitely put it in the comment section. Thank you for watching.